In section 2.3, we're going to talk about linear functions and slope-intercept form. Just to recap, slope is your vertical change over your horizontal change between two coordinates. You also may have called this your rise over run, your change in y over your change in x, and specifically you've probably seen a formula like this in Algebra 1, y2 minus y1 over x2 minus x1. Slope is going to be really important when we're working with linear equations and more complicated equations moving forward in this class. So let's just recap how I could find a slope real quick. So here I have two coordinates, -3, 7 and -2, 4, and I want to find the slope between these two. A common practice of what you might do is label your coordinates x1, y1, and so on and so forth. So I'm going to call this coordinate my x1, y1, or my first coordinate, and this -2, 4, my x2, y2, or my second coordinate. From here, I'm going to use that equation to the right there to figure it out. So y2 minus y1 will be 4 minus 7 over x2 minus x1, which is -2 minus -3. And remember that when I do minus and negative, that turns positive. So -4 minus 7 over -2 minus -3 is going to end up giving me -3 over 1, which simplifies to be -3. So my slope between these two coordinates is -3. You also could read that as down 3 over 1. A common question that some people ask when finding the slope is which coordinate to make, I guess, your first coordinate or your x1, y1, and which one to make your x2, y2. And what's important to note here is that the order really doesn't matter. So here, let's call that -2, 4 now my x1, y1, and the -3, 7 my x2, y2. We'll go through this process again, and you'll see I'm going to get the same answer. So now when I do y2 minus y1 over x2 minus x1, I get this. And I end up getting 3 over -1. So I can see here that there is a difference in the sense that the negative number's in the denominator, but overall this is going to simplify to still give me -3, or down 3 over 1. Now, just before we move on, here's a summary of different types of slopes that you might see with linear equations. Good rule of thumb that a positive slope, the line rises from left to right. So think reading like a book, you're going from left to right. If I'm going in an upward motion, that's a positive slope. Opposite is the negative. A slope of 0 is always going to be a horizontal line, and a vertical line will always have an undefined slope. Now moving on to linear functions. A linear function is any function whose graph is a line, so anything that's straight when the slope or rate of change is a constant number between every coordinate. Also some vocab. Your y-intercept will always be 0 for your x value, comma, whatever your number is, that's your y-intercept value. That's basically where your line crosses the y-axis. And your x-intercept is where you cross the x-axis. Now, tying in slopes and intercepts together gives us our most common equation that you've probably worked with so far in all of math, which is slope-intercept form of an equation. Y equals mx plus b. This equation is really nice to work with because if you have something in slope-intercept form, it's very easy to graph from there. That's the case because slope-intercept form very clearly tells you your slope or your rate of change and your y-intercept, which you could look at as a starting value or any coordinate that you could start off from and then count off for your slope from there. Just to go through some examples of why slope-intercept form is really nice for graphing, we'll look at here. So let's say I have the equation that's already in slope-intercept form, y equals 1 over 5x minus 3. Just looking at that equation without having to rearrange anything or do any other extra math here, I can see that my slope is 1 over 5. I could also read that as up 1 over 5. And I can start at my y-intercept value, which here is -3. So that coordinate is going to be 0, -3. So all I have to do from this point is plot 0, -3, count up 1 over 5, and since this is linear, once I have 2 points, I can connect them and graph it. Working backwards, it's also just as easy. So here I have a linear equation. Just looking at that, I can be able to say what it is in slope-intercept form to make an equation for it. Here, I see that my y-intercept, again, when I cross the y-axis, is 0, 2. And then I'm going to count to the next coordinate that I see. So here I'm going to count down 3 over 1, So my slope is negative 3 over 1, or I could just call that negative 3. And then plugging that in for slope-intercept form, my final equation would be y equals negative 3x plus 2. And I'd be done. So just to show why this is so important, we can see here that if something's in slope-intercept form, I can very easily graph it, or once I see a graph, put it into its own equation. So something that we're going to practice in this section is how to get an equation to slope-intercept form if it isn't there already. So here we're going to look at two examples. I want to get these equations to y equals mx plus b form, and from there, identify the slope and the y-intercept. In our first problem, I have 5x minus 4y equals 16. So our name of the game in these problems is basically just going to be to isolate y. So kind of what we did towards the end of chapter 1. I want to solve for y, get y by itself. So anything that's not y, I'm going to move to the other side of the equation. So what I'm going to do first is subtract 5x on both sides. It doesn't match up with anything, so my new equation is going to look like this. Finally, to get the y by itself, right now it's being multiplied by negative 4. The opposite is dividing. So I'm going to divide everything by negative 4, and I'm left with y equals negative 4 plus 5 over 4x. And also, for this slope, this would be a decimal, but in terms of graphing, you're going to want to leave those slopes as a fraction. It'll just be easier to work with knowing what your guy's overrun will be. So from here, now that I'm in slope-intercept form, I can easily tell that my slope is up 5 over 4, and my y-intercept is 0, negative 4. One more equation working with fractions. Now I have negative 3 over 4x plus 1 half y equals negative 1. Same process here. I'm going to move over that x term. So since it's negative 3 over 4x, I'm going to add to both sides. This will cancel. I'm left with 1 half y equals negative 1 plus 3/4 x. Also using what we learned in chapter 1, right now I'm multiplying by 1 half. So an easy way to get rid of that fraction is going to be to multiply by the reciprocal. The reciprocal of 1 half is 2 over 1, or just 2. So I'm going to multiply both sides by 2 here. When I do that, these cancel out. Multiplying both terms by 2, so distributing, I'm going to get y equals negative 2 plus 6 over 4x. That 6 over 4 is going to simplify to 3 over 2. And now I'm in simplified slope-intercept form. My slope is up 3 over 2, and my y-intercept is 0, negative 2.